Okay, this is battery safety for the club. And here are our batteries. We use, you're probably familiar with lithium ions. Ion batteries, they generally power most of your portable electronics. I'm sure most all of you have seen YouTube videos of what happens when they catch on fire. Well, lithium polymer batteries are their unstable cousins, relatively speaking. We store them either in metal boxes like this or in the ammo boxes, which are very similar, just smaller, with foam around them in order to shield them from jostling while we move them. They're also inside of that, and at all times they should be in these LiPo bags. These bags are designed to be fire resistant and will hopefully contain and stop the spread of any fires if we were to have fires. And several of these for storage. Most are stored in multi-LiPo battery bags. These are intended to have only one battery per slot. Now, the main difference between these, besides the chemistry being different, between these and, say, the lithium-ion batteries and your things. The first one is these are not in any sort of hard shell or casing. So, if I throw this across the room, there's a very good chance that the actual cells will be damaged by physical impact of any sort. So that would be the reason why we have cases around them on robots and stuff. The second thing that is very different from your lithium-ion batteries is that there's, as a whole, as a cell, your lithium-ion batteries have several sets of protection on them. They have protection. So basically, they do things so there are built into the cell. There are electrical protections against overly quick discharges, charging after the batteries have become undercharged. Because these types of batteries, they are generally not. They have to be charged in the lab once they're below a certain threshold of energy storage, because otherwise they're unstable while charging. So. Now, for our uses, the reason why we use batteries like this is energy density. These are very dense. These are also very, very good at letting the energy go quickly. So we can pull a lot of current out of them relative to the amount of current that they're storing. So, because many of our motors will draw significant amounts of current quickly. So that's the reason why we use them, but they're also quite dangerous. The batteries are firm. These batteries, if the cells were ever over-discharged or if something goes wrong, oftentimes they will start becoming poofy and they'll start bulging out. That is an indication that the battery needs to be immediately pulled from usage and not charged, and needs to be disposed as soon as possible at a proper recycling point for batteries. I believe the university probably has some, and places like that sell batteries like a good number of those will take batteries. Now with charging is the most likely time that there's going to be a problem with these batteries. Which is the reason why the batteries always need to be in a LiPo bag when we do go to charge them. So, for charging, you take an empty LiPo bag, you put it in here, you hang the cords out, and then you seal it like this. So you have access to the electrical connections and that. Uh, Part of the reason why this is important is if we're inside an enclosed space, if something does go wrong during charging and these do catch fire, in an enclosed space like this, the batteries will generate a tremendous amount of smoke. This smoke is bad for you in any number of ways. So there are chemicals in it that will displace the oxygen in your blood. So similar to carbon monoxide. There are chemicals in the gas that are direct poisons. There are chemicals in the gas that are carcinogens. And the gas also has hydrogen, will probably also have hydrogen fluoride in it, which will soak in through your skin and through your lungs, burning all the way, and in enough concentrations it can literally eat your bones from outside. So, nasty stuff. If it catches on fire inside, if you're close enough on the way out to pull the plug on the charger while it's charging, go ahead and do so, but otherwise you are going to want to evacuate the space. Those hazards there are part of the reasons why it's important to have in the LiPo bag, because you're not going to want to be doing any fire extinguishing with a class, probably should have, I believe you need a class D fire extinguisher, and probably class C, because these are not raw metals like lithium ions, but you're not going to want to be near them without proper protection. For charging, this is our charging system. With our charging systems, we have these leads, which will mate with that. And we have these, which connect in here with this, and this gives some information on the internal cells and the internal things going on that the charger can't pull from here. So the first thing we do, and we always do it in this order, is we connect these into the charger unit first. So you always want to connect these into the charger. On one side or the other. We also have on this side similar connections, and that's either channel 1 or channel 2. So we can charge 2 batteries at a time on this. But the main reason why we hook these leads up like this is if I hook this to the battery now, these 2 leads are live. If this was hooked up to the battery and I touch these leads together while it is live, these batteries can output enough current at once to actually melt this metal. Obviously, if I have this in my hand, not only do I have the potential of arc burns from the electricity, I'll also have molten metal potentially dripping onto me. So you need to be very careful that anytime there's battery plugged into this, these leads are plugged in and in a state that they cannot come in contact with anything. So once you've done that, you can connect the battery like this. Also with something like this plastic does give you protection from sparks and arcs. And if you were to actually have a large discharge, it also will provide a little bit of protection from any metal melting in there, and those contacts will quickly not be in contact. So once we have this all connected, we take it, look here. Now I'm going to pull out an identical battery to that one. So this is on balanced charge. We can adjust. There are several different things. we have the ability to draw them down to their storage state, which lowers their stored to the ideal state. We can discharge them to a given thing. We can just charge, and we can do a balance the cells and charge. We're just going to charge today. If we take a look here, these batteries are 3,000 milliamp hours. Right now, this display is showing 4,500 milliamp hours. So we're going to need to go through and reset some things. If we go into here, you can do other types. But we need LiPo there. So we're dealing with, by the markings on here, 4 cell. So 4S. Now we're not dealing with a 4,500 milliamp hour battery. You always need to check the settings on the charger, because one thing that will cause, if I'd hooked this up with 4,500 milliamp hours and charged it, there is a significant chance that we will cause a battery fire. Then once all those settings are correct, you just hold down start and enter for a little while. It'll say confirmed. It'll ask you to confirm. And then it will start charging. While batteries are charging, you need to stay in the vicinity of the batteries. If you need to leave, you can go ahead and hit escape to end the charging cycle, and then disconnect the batteries from the charger and put the batteries back away. Once you're done, batteries should always be put away when not in use. Just simply leaving batteries out when they're not actively be doing something is just a risk that we don't need to take. If you do connect it backwards, it will not power up, and you will not do any damage to the actual unit. So, and then this battery would be ready to go on the robot. These batteries both, while not completely charged, are almost fully charged at this point. But now that I've had this one on the robot, or this one on the charger for a little bit, these were matched pairs as far as discharging is concerned. I don't want to put these on the robot because power will, although probably in small amounts given how long it was on the charger, since these are different voltages, power will flow from one battery to the other, and that's not good. If you don't know if you're not sure that batteries are fully charged, we do have multimeters that you can just go in here and make sure that they are at the same voltage levels. I do have 2 batteries that were just charged, and I know that are at the correct voltages. The robot should always be operated outside of certain testings for testing states of electronics with both of its batteries in place. The motors can pull enough current. Pretty much any of the motors can potentially pull enough current under certain circumstances to pull more current than any one of these batteries can. So, as a general rule, always operate with all the batteries in. The electronics and everything will turn on. So, looking at the robot, there's one important consideration when you look at these plugs. They are somewhat protected from, the leads are somewhat protected, but depending on what is in or around the robot, you know, if this was down here by this, you know, there are places that these plugs can get where they could wind up touching metal and arc. So the first thing you do need to make sure is that the leads are not touching anything and are both in a safe state before plugging in the robot. So when you put the batteries in, especially on this robot, the battery casings and mount points are very much in a not ideal spot. So you need to be very careful about rubbing the robot against the battery against the edge of the casing here on the robot, especially when it's tight. So, and not pushing any pressure to bend or otherwise deform the battery. So once we're sure that both the other lead is not touching anything, which we just did, we can go ahead and connect power here.
Make sure that the E-stop is pressed down before plugging in any battery.
Yeah, you do not want the actual robot to be on either. That is not good for the electronics, although it is not necessarily dangerous for you. But we don't want to burn out any boards or anything. So now these are live at this point and can arc, so do be careful. You should always be paying full attention to what you're doing when hooking these in. It's just like that.
These connectors are very tight. You need to make sure that the ends come in contact together on the male and female sections, otherwise a connection may not have been made.
Or may come loose during operation. So when you disconnect the batteries from the robot, again, make sure you pay attention to how this is going. And you go ahead and take the battery out of the robot. Again, sometimes, especially with the competition cells, this can be a tight fit here with these battery cases, so just be careful. And once you're done, disconnect the battery alarms. And put the batteries back in the LiPo section from, or charge them depending on what's going on.
One note about the LiPo bags. We have two different versions of LiPo bags. One of them has fiberglass on the inside, and reaching your hand in to grab the battery leads to fiberglass shards in your hand. So be conservative with things. John, can you open that one up? It's also not good to just yank on the cords to pull them out.
No.
So you can tip it up or work it forward with your hands.
So if you at least have it where you're not putting any real pressure on them, pulling on the cords is not bad, but if you are putting any significant pull on them, you can damage the cables. Also, these bags, these multi-cell bags are, well, you could charge in them. They do have the flapping for it. We always charge in these single cell bags with one battery per bag. Just if something's going to go wrong, we don't want to take out all the batteries at once. They burn pretty furiously, and if you want to know how bad they burn, I'd suggest look up lithium polymer battery fire on YouTube. You'll get some exciting videos.